Hey, 8th grades, our learning target today is I will be able to use the tangent ratio to find the unknown side lengths in right triangles and heights of objects. You're going to need to know this to go to Valley Fair tomorrow because it's in your packet. So we're going to talk about how do you calculate the height of the wild thing without actually climbing the wild thing. Things like that. So we're going to use a little bit more high school math called trigonometry to do it. So it's not really an 8th grade math standard, but you do need it for your work tomorrow. So there's this ratio called the tangent ratio. And what it is it is a way to find the height of things. You do need to have a triangle, a right triangle to be able to do this, but it is functioning a little bit different than the Pythagorean theorem. So basically it goes like this. You don't have anything to write right now. Just kind of watch. In a right triangle, so if we have this right triangle, in a right triangle, the tangent of an acute angle is the ratio of the length of the side opposite the angle to the length of the side adjacent to the angle. Blah. A whole bunch of stuff going on there. Here's the first thing that you need to know. That this is going to be, one of these is going to be an acute angle. There you have two in there. So the acute angle means it has to be less than 90 degrees. So we're going to call that acute angle A. So what we do is we take something called the tangent of that angle. That has to be acute. You have absolutely nothing to write down right now. To find out the height of the roller coaster, if we were to measure it straight up and down, you would have to take the opposite side of this angle, so the length of the side opposite of the angle, and then you would divide it by the length of the side adjacent. Adjacent means next to. So the length of the side next to the angle. So let's say that you were 40 feet away. You would take the opposite of the angle, I'm going to teach you how to do that, and divide it by the adjacent angle. So that's kind of the background on it. Now we'll start applying it. I'm going to actually have you write down the formula in the first box. Now you should be writing. Tangent of the angle A, which it has to be an acute angle, is the opposite side length divided by adjacent. So tangent is equal to opposite divided by adjacent. Everybody should be writing right now. Okay. Opposite divided by adjacent. And then I'm going to have you, because of the video, I'm going to have you cross off box number 1 and box number 2. I think it gets a little confusing in the video, and it's a whole lot of me talking. If you're in class right now, most likely I'll be talking through that. But we're going to jump to the examples, right to example 3. So meet me in example 3 after you've written this down. Okay, so now in example 3. In example 3, we are going to try to find the height of this roller coaster. What we know is that we're 70 feet away from the roller coaster, and we know that the angle of elevation is 40 degrees. So we'll talk about how we get that in just a second. So our formula is this, the tangent of the angle. So it has to be, this has to be an acute angle. You cannot put 90 in there, of 40 degrees is equal to opposite the angle, which is x, divided by adjacent to the angle, which is 70. So we know that the angle we're talking about is 40, opposite the angle is x, adjacent the angle 70. Notice we are not using the hypotenuse in this work today. So we have something called opposite divided by adjacent. So I'm going to go ahead and erase this and start all over to make sure you understand what's going on. So the angle we're using is 40. The opposite of that angle is x. Put that on top. Divided by the adjacent, the one touching the angle is 70. So we have the hand method happening here. Tangent of 40 degrees is equal to x divided by 70. Now, I'm going to have to show you how to put this calculator sequence in, but you're going to just keep going hand method with me until we get to that step. So just go with me here. Hand method, take my hand, cover the variable x. What do I get rid of? Divide by 70. How do I get rid of it? I multiply by 70, copy, paste. Those cancel. So we get x equals. Now, pick up your calculator. And you're going to type in 70. Go ahead and type in 70. Multiply by. Everybody's typing in 70. Multiply by. And then you're going to use this button called the tangent button. I'm going to show you where it's at. So on your calculator, it's diagonal the division sign. So if you find your division sign, the tangent button is diagonal that. So that's the button you want to push. It's a TAN. It's right next to the division sign. All right, so press that button tan. So you have 70 multiplied by the tan, and then immediately type 40, and you won't be able to put the degrees in, so just 40. Tan 40. And your answer should be 58.74, and the unit is feet. So we just found is that roller coaster has a height of 58.74 feet. The height of it, without ever climbing the roller coaster, we figured out using the angle of elevation and the side lengths, is 58.74 feet high. That's our first example, example 3. Moving on to example 4. Well, before we move on to example 4, let's first talk about something called the angle of elevation. Now, you don't have to write this down. I just want you to kind of know where it's coming from. The angle of elevation is the angle from which our eyes are looking at the base, or from the point that our eyes are looking at something, all the way to the top of the roller coaster, building, light post, and so on. We use it, it's very simple. You use a protractor with a straw through it. So your eyeballs are looking through the straw and you're looking at the top. And then there's a string with a washer on it. So here's the string with the washer on it. And the string's just going to swing until your eyeballs stop at the top. So it starts off at 90 degrees, of course, straight up and down. And then you're going to just start to turn that protractor with the straw as your eyes are looking up to the top of whatever is you're looking at. Whatever angle that washer is hanging on becomes what's called the angle of elevation. So we're going to show you kind of how that looks. Here's Miss Shen outside. We're going to calculate the height of the flagpole without ever climbing it. You should be on example 4. So she's looking through the astrolabe from right here. So that's the base of where her eyeballs are currently. It does say Miss Shen's eye height is 5 feet, so we're going to have to add that 5 feet in towards the end here. So she is looking through that and looking at the top of the flagpole. The washer's hanging down. Washer starts at 90 degrees and then it starts to rotate as she's lifting her eyeballs up to see the top of the flagpole. As she does that, the washer dangles down and stops at 34 right here, becomes the angle of elevation. So we have the tangent ratio that says this. The tangent of 34 degrees is equal to the side opposite, which we don't know, the height, opposite the angle, x, divided by the side adjacent, which it means touching. Opposite divided by adjacent. So now we would solve using the hand method in this particular problem. You're going to need your calculator to do this. So hand method, take my hand, cover the x, multiply by 60 nice and high, copy, paste. So we have 60 multiplied by the tangent of 34. So 60 multiplied by the tangent of 34 gives us 40.47 is equal to x. So we know the height of our flagpole is 40.47 kind of. That's actually the height from the top of the flagpole to Miss Shen's eye height. But then we also have, she's about 5 feet tall to her eye height, so there's an extra 5 feet there. So we would be adding from the top of the flagpole to her eyes, and then from her eyes to the ground, because we have to also include that there is flagpole here. So we would add those together, and our final answer then for the flagpole height would be 45.47 feet. Flagpole from base to her eyes is 5 feet. And then our answer that we got was 40.47. So the total height of our flagpole outside the school is 45.47 feet. All right, and for this I showed all my work on the top of the screen, so you don't need to worry about this down here. Moving on. Question number 5, same thing, except it's the light post outside. So she's looking through this astrolabe. We measure the angle of elevation as she starts to move her head up. She sees the top. Washer hangs down. We calculate the angle of elevation to be 48 degrees. Now we don't want to have to climb the light pole, so we're going to use this math instead. So the opposite of the 48-degree angle is known as the x value in this case. We don't know how tall the flagpole is. It's not a flagpole, it's a light post. Sorry about that. We get x. Keep in mind, though, that we don't start measuring it until 5 feet of height. So we're going to have to add those together when we're done. The adjacent means it's touching. It's touching the side length of 18 feet. So we're going to put the adjacent in the denominator of 18. Hand method, we start to solve. Our job is to solve for the variable x. We're going to multiply nice and high by 18, copy, paste. 18s cancel. We're looking for the height of the light post. So on the left-hand side, then, we have 18 multiplied by, remember that tan button, it's diagonal division sign. 18 multiplied by the tangent of 48 means that the height of our light post outside is 99.99 feet tall. So about 20 feet. So that's 19.99. I think I misspoke there, but it should have been 19.99. Now be careful on what you're doing here, because that is the distance from the top of the light post to Miss Shen's eyes. But then keep in mind the flagpole goes all the way down to the ground another 5 feet. So we really have to add another 5 feet. So the total height of the light post is 24.99. 24.99. All right, example 6. Moving on to example 6 here. All right, so now we have the school entrance. Same kind of scenario. We do have to account for the 5 feet that she's measuring from her eyeballs. And then what is the additional height here? We're going to call it x. So same thing, astrolabe, she's looking up to the top of the school entrance. She has the tangent of 38 degrees. Remember, we have to use that acute angle, that tiny little angle, is the opposite. And that, in this particular case, again, it's x, because we don't know the height, divided by the adjacent, the side length that's touching. This time it's 42 that's touching. Hand method kicks in. We're solving for the variable x. We're going to multiply by 42, copy, paste. So we have 42 times the tangent of 38. 42 multiplied by the tangent of 38 is 32.81. So that's 32.81 feet. So that's from the height of the school entrance down to her eyes, plus the 5 feet to her eyes. So the total height of our school entrance out front is 32.81 plus 5 feet is 37.81 feet tall. That would be dangerous to climb, so we figured that all out just using good math. You do need the angle of elevation. You need to know how far you are from it, and you're able to get that information. All right, gang, last problem of the day. Number 7. What about the height of the ceiling in the locker bay? Now, that's something that's probably less scary to climb up there and actually calculate the real elevation. So a couple things that we would need to do is we would need to create a right triangle. So we have this right triangle happening right here. So Miss Shen is looking through the astrolabe. We need to calculate the angle of elevation. We need to know the distance that she is from the locker bay. We don't know the height, but we're going to have to add the 5 feet as we've been doing. So we're going to add those together as we go. So we're going to try to find that height. Now it's easy to calculate the distance that she is away. It says that she is 17 feet away. It says the angle of elevation is 28 feet. So our job is to figure out the height of the locker bay without actually climbing it. So if we do some good math here, we're going to say that the tangent of 28 degrees is equal to the opposite of the acute angle. Opposite is x divided by the adjacent. The adjacent means that it's touching. We're touching at 17. Hand method kicks in. We're going to solve for the variable x. We're going to multiply by 17, copy, paste. Those cancel then, so we get x equals, we have 17 multiplied by the tangent of 28. So we get 9.04 feet. So we know that this is 9.04 feet. Plus the 5 feet from her eyeballs means the grand total, the height of the locker bay then is 9.04 plus 5 is 14.04 feet. That's the grand total height of our locker bay. All right, so Valley Fair tomorrow. You need to be able to go tangent ratio. Tangent is equal to opposite over adjacent. So for our summary, remember that tangent is only for right triangles. But you are not using the hypotenuse. A lot of times kids think we're using the hypotenuse because it's a right triangle, but we're not using the hypotenuse in this particular case. And the formula is the tangent of the angle is equal to opposite over adjacent. Go ahead and get those two notes down in your summary. And your homework is to do the next 6 problems on the back. Now, I'm not going to go through those problems with you. However, after you're done calculating in the summary, because it is tomorrow and you're going to Valley Fair tomorrow, I want to make sure you understand what you're doing. So I'm going to actually do a quick screenshot of the answers with work just for this particular lesson, so you're able to make sure you're in good shape for tomorrow's work at Valley Fair. So finish up with your summary right now. And just real quick, here are the answers on this page. I'm just going to kind of scroll through the video so you can pause at any point just to make sure your work is solid for Valley Fair tomorrow. Just kind of scrolling, scrolling, scrolling. Scrolling, scrolling, scrolling. So then you can pause the video at any point, make sure you're in good shape for tomorrow's work at Valley Fair. Okay, so your homework is to do these 6, due tomorrow. Have a great time at Valley Fair tomorrow. Have a fabulous night, 8th grade.